Welcome to Fragmented, a software developer podcast where we talk about building good software and becoming better developers. My name's Donn Felker.
And I'm Kaushik Gopal.
Welcome to the show. Before we get started here today, I wanted to tell you about the relaunch of AndroidJobs.io. Android Jobs is a job board that I launched many years ago, and I just recently relaunched it with a brand new design and on a brand new platform. If you're looking to hire an additional Android team member, or you know of somebody that wants to hire an Android professional of any sort, that includes developers, designers, anything of that nature, then please let them know about AndroidJobs.io. All job postings are free at this time during the early release phase. Eventually they'll be paid, but right now they're all free at the time of this recording. So please go to AndroidJobs.io and you can post a job for free, or if you're looking to see what other jobs are available, you can also go there and plug your email address in, and we'll start emailing you here very soon, letting you know weekly about the new jobs that are available on AndroidJobs.io. Again, check it out at AndroidJobs.io. Everybody, welcome back to the show. Unfortunately, Kaushik is not here today, but soon enough he'll be joining us. And we're going to be talking about some cool stuff today and going forward in regards to a topic that I'm very interested in, which we'll talk about here in a second. However, before we do that, I wanted to say thank you to all the listeners who have been listening to the show over a number of years now. We really appreciate your support. That's the big reason why we're still doing this. And if you're just joining us here on Fragmented as a new listener, thank you for joining us. We are a software podcast and we talk about all things software related. Now, if you do go back further in our catalog, you will realize the first 150 to almost 200 episodes were all mainly Android based. Kaushik and I were in the trenches Android developers, as we said early in our episodes, and we wanted to have a show to talk about that. However, as things progressed, in both of our careers, we found ourselves doing far more than just Android. Half the time I might spend my time in Rails, or I might spend it in Node.js or React or TypeScript or Python. And the other part of it I might spend in mobile, which would include Android, sometimes Flutter, sometimes a different language. Kaushik works with his own set of technologies as well. So we felt it only necessary to broaden our horizons and talk about other things. Which brings us back to our current topic today. If you've listened to this show for any length of time, you'll probably have realized that my favorite book of all time for software is called Working Effectively with Legacy Code. It's a book by Michael C. Feathers, also known just as Michael Feathers. And this book was really life-changing for me when I first started reading it. And I think I picked it up when it first came out back in 2005 or 2006, whenever that was. And the thing that was really interesting to me that really made me pick up this book were the chapter titles. Now, so for example, here's some of the chapter titles that just to tell you about how you might find it interesting too. Again, this book is about working with legacy software, which is probably one of the most boring topics in the world if you think about it. Old software is hard to change. However, we all have to work with it, and it gets really annoying. But this book really shed some light on how to improve the software so you can start making changes and so forth. And so these chapter titles really hit home. So let's just talk about a couple of them here. Chapter number 6, the title is, I don't have much time and I have to change it. So I don't know about you, but that basically resonates with me. Chapter 7, the title is, It Takes Forever to Make a Change. Yep, been there. Chapter number 9, I can't get this class into a test harness. Exactly. Been there before. And chapter 13, this one is so good. This one is, I need to make a change, but I don't know what tests to write. I still feel like that all the time lately. Chapter 14, if any developer can, which is within the last 10 years, has run into this problem. Chapter 14's title, Dependencies on Libraries Are Killing Me. And chapter number 16, this is the one that's like, I think this is the one that kind of sealed the deal for me when I really was reading the chapter titles and made me want to pick up this book. And chapter 16 is, I don't understand the code well enough to change it. And there's a bunch of other chapter titles, which we'll talk about inside of here, and it just keeps going and going and going. But what I would like to do for the next number of episodes, and I don't know how long I'll go on for, is talk about some of the chapters in this book and what they mean and how they apply to you as a developer and your job and what you do for a living, the craft of software development. So let's just really hop right into it. Now, again, I don't know how long I'm going to go on and talk about these things, meaning I don't know how many episodes we're going to do. I may only do 2 or 3. I may do 5. I may do 10. I'm not sure. We'll see how long this moves on. And if you really like this content, podcasts like this, please let me know and I'll continue to do them. Just send me a message on Twitter or comment anywhere where we publish the podcast. It would be greatly appreciated. All right. So the first thing we're going to cover is very early in the book. I think it's like page 17 or 18 here. And it's known as what Michael Feathers describes as the legacy code change algorithm. And there's an algorithm that he lays out anytime you need to change anything in a legacy code base. And it's basically a 5-step process. And what I want to do in today's podcast is talk about the legacy code change algorithm and what it means in each step. So the 5 steps are: step number 1, identify change points. Step number 2, find test points. Step number 3, break dependencies. Step number 4, write tests. Step number 5, which is the final step, make changes and refactor. So as you might know, what the purpose of working with a legacy code is because we have to change the code. We need to make changes to it. We might have to improve it. We might need to add new features. We might need to fix a bug. We might need to handle some type of performance situation that has maybe popped up because of just maybe the data has gotten really large and we're not using an optimized way of processing that data. So the legacy code change algorithm here is basically a series of steps that you can go through to implement these various different changes. And throughout the book, he talks about how you can use different techniques and so forth to implement all these different types of things. So let's just talk about each one of these briefly today. So number 1, we have identify change points. What does that mean? The change points really just mean these are the places that you need to make changes. Now, here's the thing. This depends very sensitively on the architecture of your application or the legacy application. And if you don't know that architecture, there are a couple of chapters in here, which I didn't mention. Chapter 16, I don't understand the code well enough to change it. And chapter 17, which is something we're all familiar with. Chapter 17 is titled, My Application Has No Structure. Also known as, in my words and many other words of other professionals, spaghetti code. So identify change points. It's a pretty short one. We're just trying to figure out where we need to make a change. Could be on a particular screen, could be on a web page, wherever we need to make it. So we need to identify where we need to make the change. Of course, that's going to be step 1, pretty small. Number 2, title is of the legacy code change algorithm is find test points. Now, sometimes it's pretty easy to find these test points of where you need to make a change. Perhaps it's a function, perhaps it's a class, perhaps it's something in your application. You can find it very easily. But however, in legacy code that you're not familiar with, this can often be very difficult. So again, there are various chapters we'll talk about in the coming episodes. For example, this is a good one here at chapter 11. I need to make a change. What methods should I test? And I need to change dependencies and so forth. So we're going to talk about those things. So you got to find where your test points are going to be located. And again, with legacy code, that can be rather difficult because you kind of have to navigate through this huge spaghetti code of this ginormous mess that makes no sense to you because perhaps it's written a decade before you even touched it, which I've encountered multiple times. So we've identified where we need to change it. Now we need to find a place where we can test these changes. And this can be very difficult. We might have to introduce some type of seam or a shim in between different classes so we can kind of break some dependencies. We might have to extract an interface. We might have to do some type of abstraction, kind of maybe even write a full end-to-end test so I know that my inputs and my outputs are matching. So there's a bunch of different places here, but we have to figure out where our test point's at. And again, this depends on your architecture. Do you have classes? Is it one huge monster file that's 10,000 lines long? And how are you going to break that apart? Are methods 600-700 lines long? What's the best way to do that? So you have to find out where you can test it. And that's going to vary on a case-by-case basis. You have to look at the code. So let's hop into number 3. You have to break dependencies. Now, one of the difficult things about breaking dependencies is with a lot of legacy software, especially if it wasn't written in a way in which testing is easily facilitated, meaning that you're not using maybe a dependency injector in a statically typed language, you can find yourself having to create a humongous object graph to test one particular class. Maybe it's one particular service layer of the application, but to build that service layer, it needs something else. And that thing needs something else. And that thing needs a file system. And that other thing needs a network. And that other thing needs this. And that other thing needs that. So this is where it gets really hairy. This is the real hard part here, in my opinion, of how can you break these dependencies so that you can get this thing under test. So which is our next step, which is writing tests. How can we get there so we can write a test? And chapter 23 of this book talks about this actually. It says, how do I know that I'm not breaking anything? And so at a high level, one of these ways that you can do that is literally writing a couple of end-to-end tests around your legacy application. Now, there's different ways, which we'll talk about here in a second, of how you're writing tests. And Michael Feathers puts this very perfectly. So I'm actually going to skip ahead for a second. And I'm going to quote him here. He says, I find that the tests I write in legacy code are somewhat different from the tests I write for new code. 100% wholeheartedly agree, because the tests that I write for legacy code are basically safety. They're like safety pads that I have laid out on the ground for myself in case I fall down, which I'm breaking the code. This test basically is just wrapping the entire thing. It may have to execute. It may take a long time to execute, but at least I can verify the behavior. I didn't break anything. So if I'm going to write tests for new code, well, I'm already going to perhaps be breaking my dependencies apart. I'll be relying on interfaces or some type of thing that allows me to break these dependencies very easily so I can write unit tests and just make small little unit tests and easily test each individual component versus having to write a huge monster integration test, set up huge environments with networks, file systems, databases, everything. But in a legacy environment, you don't have that ability to say, hey, I'm going to have all these different small cohesive units. It's just this huge spaghetti mess. And so you have to figure out how you're going to break these dependencies apart. So what you need to do is, one of the words he uses in this book is incisions. You have to figure out where you can make an incision inside of the application. And very often this is going to be between different classes. Now, one class, again, maybe we'll talk about a service class. It handles some processing of data, but that class instantiates a new database class to write the data to a database. Well, what you might need to do is take a look at that database and extract an interface from it, and then rely on the interface and figure out a way to pass that interface in. And so, for example, one way that I have done this many times is inside of a method, I would see that a class was being instantiated. So maybe it's, my database layer. And say my database layer, DB equals new database layer. It's literally a concrete implementation right there inside of the method. How do I break that? Well, I might go to my database layer and extract an interface on it. So I might use the tools in IntelliJ or some other platform, extract an interface off of that. Then back in my other class that I'm trying to wrap a test around, I might go up to a constructor and then rely on the interface. I might have a field, say, hey, here's the interface, be called maybe my database layer interface. I'm just going to use some random name here. And then inside of the constructor, when the constructor instantiates, I would pass in a new instance of the database layer. So now anyone who's calling into it would then by default use the instance just built inside of the constructor. However, if I want to write a test for it, I could have an overload that allows me to pass in a different instance, which then I could use some type of mocking library, or I could use a fake or anything like that, my own custom object that would allow me to test without having an actual database up and running. So that's actually one of the examples he actually covers here in the book. And to tell you the truth, that's where I learned it, was right in this book. So these type of dependency problems are going to show up all over the place. And I've talked about this the longest so far, simply because it's one of the most difficult areas, because you'll find one class relies on another class or relies on another class. And you really have to act like a surgeon and figure out where you're going to make this incision inside of your code to kind of break this dependency chain so I can figure out how I can write my tests. So that's going to be the biggest one there, is finding a way to break these dependencies apart. Now, I'm not talking about dependencies on libraries, though you may depend on a library. And if you are depending upon a library, well, what do you do then? Well, what you can also do is you can create what's also known as like a gateway type pattern. And there's a couple of names for this. It could be called a facade, could be whatever. I like to call it a gateway. And what a gateway is let's say that you're using a class and it has a bunch of static methods on it, right? And it's from another third-party open source library, and it just has static methods. You call on it and it does something. Those methods may go out to the network. Problem is, that makes it very difficult for you to do anything because those are static and they're almost impossible to mock out in some statically typed languages. So what I'll do is actually create another class, and I'll call this my database layer gateway. Let's say that was, our database layer was all static calls. And this class, my database layer gateway, has an interface on it that basically has the same exact methods. And what I'm really doing is just creating a wrapper. That's all I'm doing. I'm wrapping the existing static gateway and kind of replacing that code in there. It's still calling the same exact code, but now I am kind of wrapping it around an abstraction that I can then later provide a fake or a mock for to allow me to do that. So you'll start to find a lot of similarities between these approaches. Now, that doesn't mean that you're eventually going to leave that gateway in there. You may refactor it later, but these are building blocks. These are steps from you getting your code, which is in a legacy format, into a much more maintainable format, which is testable. All right, so we've talked about these breaking dependencies for quite a while now. Let's go to step number 4, which is write tests. And to reiterate what I said before, Michael Feathers, in quote, says, "I find that the tests I write in legacy code are somewhat different than the tests I write for new code." 100% agree with this. You're going to write your tests way different because you just need to wrap your existing application, which is the legacy application, in some type of test, and you need to make sure that you don't break anything. And so whatever way you can accomplish that right now to get that job done is what you might need to do. Now, it might not be the prettiest thing in the world. It might not be the best thing in the world. And what you also have to realize is you're probably going to throw this code away pretty soon, simply because this is just a safety harness right now for you to allow you to make a change until you can decide to refactor even more later, which then will allow you to create a better architecture so you can start writing better tests, more unit tests. And then eventually, once everything is wrapped up and covered, you can then finally get rid of that huge, archaic, big mess that you created that tested the legacy code in the first place, because you already have it tested with all the other, perhaps, units and so forth. So this brings us to number 5. After we've written our tests, we can then verify. We run our tests. We can see the state that's happening. We can verify things are happening. Now, finally, this is where we can make changes. So step 5, make changes and refactor. Now, Mike Feathers recommends using the TDD approach. TDD does have its validity. I do believe in a lot of TDD's principles. However, there are cases, in fact, many cases, where I don't know what I don't know. And that's one of the things that's hard about TDD is I don't even know where to write the test because I don't know what I don't know yet. And so this is where a lot of integration tests can come in, or end-to-end tests can come in really helpful in a legacy code scenario. I can write a test that covers all that legacy code. And then eventually, as I start becoming more and more familiar with the legacy code, I can then start breaking it apart into more manageable chunks and writing tests around that. So it's kind of a familiarity thing. If I don't know what to test or how to test it yet, I might just kind of have to play with it and just start experimenting. Now, my original test that I wrote to verify that the behavior still works, that's going to catch all of our big problems. So here on step 5, you're just going to make your changes. And then as you're making these changes, of course, you're going to write your new code in a method that's going to allow you to test them. Now, you might be extracting interfaces, creating more abstractions, introducing maybe dependency injection. Of course, I don't advocate making too many changes at once because that can just be risky in itself. But you're going to write some good code and you're going to start moving your application towards a better structure. Now, you want to do this in baby steps. And this is exactly what he quotes right in the book. Don't, as I said before, don't go hog wild and say, all right, well, we're going to introduce dependency injection and we're going to change this into an MVVM approach because it's a huge... No. That's way too much. Start with baby steps. Start small. get it working, slow incremental improvements, and then continually write new tests. Continually update, continually write new tests. Don't bite off more than you can chew. This will come out to bite you in the rear end real fast. So that is the basic fundamental legacy code change algorithm. To recap the steps here. Number one, you're going to identify the change points. These are where you need to make changes. Number two, you're going to find the test points, which are where you're going to actually be able to, and what you need to test. Number three, you need to break those dependencies, because most likely in that legacy code, there's a bunch of dependent stuff, and you need to figure out how to break that stuff apart. Number four, you're then going to write the tests that verify the current behavior of the application. And then you can verify that you didn't really break anything. And finally, step five, you're going to make changes and refactor. This is where you're going to write the new code, where you're going to change the existing code, and then you're going to write some more tests to verify the new behavior as well. So that's the legacy code change algorithm. That's kind of the basis for a lot of what you're going to see in working effectively with legacy code. Again, I'm going to talk about all different types of things. This is one of my favorite books on software development in general. The book actually, I think the examples are all in Java. And when I read this, I was not a Java developer. I was a PHP and .NET developer and Rails developer. Before I'd even got into Android and Java is when I read this. And it doesn't matter. Don't let the language off-put you. So if you're a Python developer and you're listening to this and you think like, I don't want to read Java, don't worry what language it's written in. All of these concepts apply across the board. You're going to run into legacy code all over the place. It doesn't matter if it's Python or Java or Kotlin or Swift or whatever. You're going to run into legacy code in your career. And knowing how to work with that legacy code is a superpower. I'm not going to lie. You're going to walk in, you're going to understand these steps, the legacy code change algorithm, and the things that we'll be talking about of how to break these things apart inside of your app, of the legacy application, is going to help you grow in your career immensely. So stay tuned. We'll be talking about more of these topics, more of these chapters here in Working Effectively with Legacy Code. Again, that's a book by Michael Feathers. I'll put the link in the show notes. Thanks for listening, and I will catch you on the next episode. Hey folks, before you get going, don't forget to check out androidjobs.io. All job postings are now currently free during the early release phase. And if you're looking to see what other jobs are available, you'd be surprised at some of the jobs that are out there. Almost all of them are remote friendly. Tons of great companies posting there. You can sign up and get notified of new job postings on a weekly basis. Check it out at androidjobs.io. Thanks.
That's it for the show, folks. Fragmented is hosted by Donn Felker and me, Kaushik Gopal. We edit and produce all the episodes here on Fragmented. You can find more Fragmented episodes at fragmentedpodcast.com. Thanks for listening, and we will catch you in the next episode.